Hello dears, welcome to chemistry class. Today we are going to begin a new chapter of plus one chemistry, that is chapter number 1, some basic concepts of chemistry. So what is chemistry? Chemistry is a branch of science which deals with the study of matter, its constituents, its properties, its preparation and structure. That is called chemistry. These aspects can be best described and understood in terms of the basic constituents of matter, that is atoms and molecules, and hence chemistry sometimes called it is the science of atoms and molecules. It is the science of atoms and molecules. Now let us see what are the importance of chemistry. You know, chemistry plays a major role in almost all sorts of life. That is, you know, when we are nowadays we are facing a problem of population explosion, and automatically this population explosion leads to the shortage of many natural resources like a resource of food, then shortage in many other things like the diseases, and then malnutrition, etc. So many such problems arises nowadays, and here chemistry plays a major role in overcoming all these problems, and chemistry has helped man in overcoming almost all problems to a great extent. And you know, the shortage of natural resources and also the shortage of energies leads to many problems. So in order to overcome these problems, chemistry has helped man in overcoming almost all problems to a great extent. Now let us discuss some of the importance of chemistry and what are the different aspects of chemistry in our daily life, and let us discuss some of them. That is the first one, chemistry in agriculture. So chemistry plays a major role in agriculture, you know, that is it is used in testing soils, then producing suitable fertilizers and pesticides, because all these are related to chemistry, and then for protecting seeds, you know, various substances are produced. So that is involved in the chemistry. And then chemistry in medicine. Chemistry plays a major role in medicine, that is the discovery of antibiotics, antipyretics, analgesics, antiseptics, sulfur drugs, etc. Then another one that is the purification of water, and then it is the discovery of drugs like cisplatin and Taxol that plays a major role in the cancer therapy. And then in textile industry, that is, you know, it is also play a major role in textile industry, because you know the discovery of synthetic fibers like nylon, terlin, dacron, etc. that play a major role for the shortage of natural resources like cotton, linen, etc. Then shelter, the invention of cement, steel, bricks, then GI pipes, etc. that is galvanized iron. These are very much helpful in our daily life. And then lifestyle, so the discovery of film, photography, cosmetics, etc. These are some of the applications of chemistry in our daily life. So chemistry plays a major role in all these fields, and not only that, in addition to this, that is nuclear chemistry. One of the major contribution of nuclear chemistry is that atom bomb, hydrogen bomb, etc. all these are related to chemistry. So chemistry plays a major role in our daily life. Then next we are going to discuss matter. So what is matter? Anything which has mass and occupies space, that is called matter. Matter means anything that has mass and occupies space, that is called matter. So all the substances around us is a matter. See this this marker is a matter, book is a matter, chalk, board. So all the substances around you and yourself is a matter. Anything which has mass and occupies space, that is called matter. And physically we can classify matter into three. That is, physical classification of matter is that matter exists in three states. Mainly they are existing in three states, that is solid, liquid and gas. Solid, liquid and gas. We know in solid the particles are closely packed, and then the force of attraction between the particles are very strong, so they are very much closely packed in solid state. And in liquid state they are somewhat loosely packed as compared to solids, so the interparticular distance is more as compared to solid. And what about in gas? The particles are very loosely packed, and then the particles are free to move in gas state. And about their that is solids, they possess a definite shape and definite volume. Solids, they possess definite shape and definite volume, and liquids, they have definite volume but they don't have any definite shape. They will take the shape of the container, because when we take some water in a glass tumbler, so that will take the shape of the glass tumbler, and also they have a fixed volume but they do not have a fixed shape. And when you pour this glass of water into any other vessel, for example in a standard measuring flask, so that will have the shape of the SMF or standard measuring flask. So it will take the shape of the container but they have a definite volume. And what about gases? Gases, they do not have any definite volume and definite shape. They are the particles present in gas state, they are free to move everywhere, and they are spread over the space available to them. So that is in the gas state. So this is the physical classification of matter. And chemically matter can be classified into two categories. So chemically we can classify matter into two, that is pure substances and impure substances. So pure substances impure substances are otherwise known as mixtures. Okay. So chemically we can classify matter into two, that is pure substances and impure substances. So pure substances, again we can classify them into two categories, that is elements and compounds. Elements and compounds. So what are pure substances? Pure substances are the substances which are made up of only one kind of particles, that is called pure substances. Pure substances are the substances which are made up of only one kind of particles. They are known as pure substances. And these pure substances can be there are two types, that is elements and compounds. Elements and compounds. So what are elements? Elements are the pure substances which contain or which are made up of only one kind of atoms. They are known as elements. Elements are pure substances which are made up of only one kind of atoms. Example for elements, that is iron, then oxygen, magnesium, helium, etc. All these are examples for elements. Elements are the pure substances which are made up of only one kind of atoms. And compounds. So what are compounds? Compounds are pure substances which are formed by the combination of two or more elements in a fixed proportion by mass. So compounds are formed by the combination of two or more elements in a fixed proportion by mass. For example, HCl is a compound. It is formed by the combination of one hydrogen and one chlorine. Then water, that is H2O molecule, it is a compound because it is formed by the combination of hydrogen and oxygen in a fixed ratio. Then ammonia, it is a compound. Then C6H12O6, it is a glucose, it is a compound. So there is a definite proportion between the combining elements in a compound. So compounds are pure substances which are formed by the combination of two or more elements in a fixed proportion by mass. That is known as compounds. So what are mixtures or impure substances? It's a form of matter in which two or more pure substances which are physically mixed in any proportion. That is called impure substances. For example, alloys, then ink, milk, soap solution, etc. All these are example of impure substances. These are formed in which two or more pure substances, it may be elements or compounds, which are physically mixed in any proportion. That is called impure substances. Okay, and impure substances we can again divide them into two, that is homogeneous and heterogeneous. Homogeneous and heterogeneous. So what are homogeneous mixtures? A mixture is said to be homogeneous in which all the components are uniformly distributed and there is no visible boundary of separation between the components. They are called homogeneous mixture. Homogeneous mixture means a mixture in which the components are uniformly distributed and there is no visible boundary of separation between the components. Example, this salt solution or sugar solution. You know, when you take a sugar solution and you dissolve it, when you dissolve sugar in water, and it forms sugar solution. And then when you take some samples from any part, from one part and another part, so in all parts they are uniformly distributed. The sugar is uniformly distributed. We will not get a different taste. We will get same taste in all parts. So that is called a homogeneous mixture. And then what are heterogeneous mixture? A mixture is said to be heterogeneous if the components are non-uniformly distributed and there is a visible boundary of separation between the components. They are known as heterogeneous mixture. That is, the components or the particles present in that mixture are non-uniformly distributed and there is a visible boundary of separation between the components. For example, sand and water. When you mix sand and water, we can see that sand and when we keep it for some time, there will be a different layers. So a visible layer of separation between the components can be seen in the case of heterogeneous mixture. Then oil and water. So there will be a boundary of separation between these. It will be two layers. There will be two layers. So that is called a heterogeneous mixture. So I hope it's clear. So that's all for today. Thank you.